In our project, we started with a database schema for a movie database with additional movie information as well as cinema data, for example halls and tickets. To evaluate the schema, we first needed to populate the database with test data. We could use the data then to run analyses, especially with Google Fusion tables. Additionally, we created a web interface to make the data conveniently accessible to human users. In this presentation, we want to show you how we accomplished these tasks. Before we can go into depth, we'll first introduce you into our database schema that will act as the foundation of our further work explained in this presentation. After this introduction, we will continue by giving you an overview about the data sources we used for the database population. Then we will explain how these data sources were used to populate the database. We will also explain how additional data was randomly generated. Once we made it clear how the data was gathered and generated, we will then show you some analyses we ran on the data. First with Google Fusion tables, second with a custom web interface we created. So let's start with the introduction into our database schema. The first core entity of our schema is the movie. A movie has numerous attributes, describing it in detail, like its title, but also the release dates and its runtime. Note that we will only show the most relevant attributes in the remaining parts of the presentation. Besides that, each movie can have a set of genres and keywords that can provide further information about the movie. Also, movie can be part of a film series and is assigned to a studio. Let's take a look at some other aspects of schema related to the movie now. The schema allows users with accounts to rate movies. Additionally, it allows users to leave comments for the ratings. To make this possible, the rating association is transformed into an entity, which is then associated with an account. Another aspect of the schema are movie persons. To represent person taking part in the movie, the participation association is used. To further describe the way a person participates in a movie, it is transformed into an entity that is specialized into an acting participation, a writing participation, and a directing participation. Further, the schema supports awards. Awards can be given to movies as well as person participants in movies. To enable the medial enrichment of movie and person information, the schema supports the entity type media. This entity type can be associated to movies and persons. Media is specialized into photos and videos. These presented entity types and associations make up the first part of our schema that mainly deals with movie information. Next, we will take a closer look at the parts that are more relevant for the operation of a cinema. So, let's take a look from a different perspective on the movie entity. The first aspect we'll take a look on is the language. A movie can have different language versions, but always has some original language. Since there are different movie formats like digital 2D or 3D film as well as old analog film, we also need to consider the movie format. Having a movie language version in a specific format results in a movie version association. Such a movie version can then be associated with an individual show to a movie sitting. Since a movie sitting can also consist of multiple movies, there can be multiple shows per sitting. Each movie sitting needs a place where it can take place in. Therefore, the schema contains the entity type cinema hall that is associated with the sitting. However, not all cinema halls might be able to show all types of movie format. Therefore, the schema also supports specifying the movie formats a cinema hall can show. Of course, a cinema hall is not empty, but has a number of seats. Seats are specialized into normal or luxury seats that have some more comfort than normal seats. To actually make money with the cinema operator wants to sell tickets. On the one hand, tickets specify the seat they are assigned to, and on the other hand, the movie sitting that the owner can access. And with that, we also introduced you into the second half of our schema, which concludes the presentation of the necessary foundation of this presentation. Now that we've shown what kind of information are needed for the population, we'll now present you the sources we get this information. We classify our sources into three main categories. First, we have sources that provide us with real content. That means that these sources contain meaningful information, especially about movies. Second, we have sources that provide us with dummy content. Dummy content is data that does not necessarily contain meaningful information, but tries to imitate it as well as possible. At last, we generate completely random data for the part of our schema that we cannot populate with any existing sources. Let's take a closer look at the real content sources. The main real content source is the movie database, the moviedb.org. We get most of the information about movies from this database via its open API. Particularly, we get information about movie genres, keywords, and participating persons, but also about reviews, accounts, and media. A second content source is the United States Library of Congress webpage. It provides us with a list of language codes according to the ISO 6392 standard. Let's take a closer look at the dummy sources now. The first dummy source we used is the random text provider of loripsum.net. This text provider creates text snippets of configurable size that appear like actual text at the first sight. We use this provider to populate our review comments. The second dummy source is a list of some popular movie awards we researched manually on the English language Wikipedia article List of Movie Awards that we added to our generation code. The next sources are a list of possible cinema hall names we came up based on our own cinema experience, as well as typical movie sitting start times. And the last dummy source is another list of movie format types we thought of, like analog or digital film and 2D or 3D projection. The remaining parts of our schema were populated with randomly generated data, for example to create sample business data for the cinema. Let's take a look at this as well. The seats in the cinema hall and the tickets for movie sittings are generated randomly based on some configurable parameters we created in our generation system. As a different kind of generation, we have the random assignment of entities to each other. We look up random entities in one table and randomly assign entities from another table, thereby creating a new relationship. We do that for the movie formats a cinema hall supports, the movie versions that are available for our cinema, and the movies that are shown in our movie sitting. For the generation process, we used one main PHP script to handle the generation of all types of data sources. It covers the central database handling, includes a step to reset database content, and include all individual scripts to generate the content. We used this construction to allow a better coding practice, a distributed coding, and also to allow generation of subset of tables. To show our approach of data extraction, the next slides will contain some code snippets, and I will try to explain them shortly. We use parameters in most generators, for example to control the amount of entries to generate. To retrieve data from online sources, we use the PHP file getContents function. To extract only the relevant parts of the source content, we use some mapping functions. Finally, the data is inserted into our database. To keep the handling of our dummy data quite easy, we also use parameters to control the amount of entries and range for some attributes. Several types of helper methods can be used for the generation of random content, for example for building combinations of items into arrays. Here the possible names are chosen randomly and enumerated to create a sequence like hall 1, hall 2, hall 3, and so on. Again, the data is written to the database using the central database connection.
But what if we want to visualize our data? Therefore, we use Google Fusion tables. In order to create the ranking of languages the most movies are available in, we had to join the tables movie, movie language version, and language. With Google Fusion tables, we now can set up the SQL query by this interface. For the given example, we choose these settings. After applying these settings, Google Fusion tables gives us this visualization. As you can see, the most movies in our database are available in English. We repeat this process for the age of participants. Therefore, we have to join the tables movie, participant, and person. Since some persons in our dataset have no year of birth, we have to filter only the persons that have a date of birth. You can see that in the last line in the where clause. Again, here are the settings we chose this time. As you can see, we used a little transformation to transform the date of birth in the actual age of the participator in the movie. The visualization shows that the youngest actor was actually Larry Sims, followed by Hallie Eisenberg, and so on. If we reverse our visualization, we see that there's a Jane Austen that was actually 230 years old when she played in a movie. We can assume that this is a mistake in the database. The next visualization is the sum of years of life that participated in a movie. As you can see, we choose the same query as in the example before, but with different settings. Now we take the sum of the age in film and we'll get a different result. Here we can see that Mr. Smith Goes to Washington had either many participants or they were quite old. Reversed, we can see that the movie Life in Loops in our database had maybe only one participant, or the participants came mainly from the kindergarten. So let's leave the age behind us and see our next visualization for award comparison. To choose and promote movies for classic movie nights, the cinema needs an overview over the awards of the past movies. To achieve this, the tables movie and award needed to be joined in a single view to associate the award count to the certain movie titles. With Google Fusion tables, we chose to count the number of awards for each title. The visualization shows the movies with the most awards, starting with Groundhog Day. But let's go on. To get insights in the success of certain movies, the management needs an overview about the total revenue of each movie in comparison to other movies. To achieve this, not only the two tables movie and ticket have to be joined, but also the individual show has to be taken into consideration. This can be explained as followed. A ticket is always bought for sitting. A single sitting can consist of several movies. Therefore, only some relative part of ticket price can be aggregated for a movie. In the settings, we choose that we want to get the revenue a movie made sorted alphabetically by the title. With these visualizations, you can get a good overview over revenues movies made. To show other types of visualizations you can realize with Google Fusion tables, the next one is the movie collections. Since the cinema often plans doubles and triples, an overview over all possible movie collection is required. An appropriate visualization, therefore, is a network graph that weights collections with more parts higher than others. After joining all necessary data, we this time choose to show links between film title and film series. The visualization is quite interesting. Here we see film series like Proletariat Collection and Their Children, Ariel and Shadows in Paradise. That will give a really classical movie night. To keep track of seasonal trends, an overview over the ticket sales over time is required. This can simply be achieved by a join of the ticket and movie sitting table. To visualize it in the correct way, we choose the category date, and for the value we count the ticket IDs. As you can see, the ticket sales of the last 100 days were quite variable. But you can do even more with Google Fusion tables. So you can include geodata and show visualizations connected to these geolocations. In this example, we choose the places of birth of all persons in our database. We change the column type place of birth from text to location in order to let Google geocode the locations. Also, we had to change map visualizations to heat map. Here, the visualization that shows that most of our persons are from Europe or the United States, and quite few one from Japan. So with this visual impact, we will end the section Google Fusion Tables and continue with our web interface.
Here, the introduction to our website. We created a website to enable our management to make informed decisions. The homepage provides a direct overview over key questions of the business regarding the last year's sold tickets. A second chart shows information about the best genres of the current accounting month compared to the last month values. The graphs are highly functionable and support actions like filtering. On Additional tab, you get the same information listed by revenue. The graphs are even able to drill down to several data points, which is amazing, isn't it? On the second step, the user can navigate directly to a given movie. In this case, the well-known movie The Fifth Element. In the movie details, we provide several data like the description of a movie as well as some analytic tools regarding the ratio of sold seats. Other information like the release date, the genres or awarded prizes may be of interest as well. Also present is the average rating of all our users. So, how would you rate The Fifth Element? I'll give it a 7. Finally, we list all participants like writers, directors and actors of a movie, including an amazing image and, if available, the name of the role the person played. The entry of a person, as well as every other item in our web platform, is directly linked to the specific details page. Amazing! In this case, the profile page of Mila Jovovich. Here the user will find a description about the person. Scrolling down, the user is provided with a list of every movie the person participated in. As you can see, Miller might be an active actor, but she's a poor director and writer. No movies for her in these roles. Using the navigation, we can move to the different cinema halls Cinemoon owns. In the details of a cinema hall, we get a good overview over the different seat categories the cinema halls offers to the customer and in which rations the categories are present. Additionally, we list the details of every single seat, like with no additional effort. As you may remember, a sitting refers to one specific event a customer can visit. It is allocated to a hall and can have multiple movies assigned. For example, a movie could be watched with all his prequels in only one sitting. If we open the details, we are getting all the information about the specific sitting. This includes the details for all movies shown in this sitting, as well as information about the sold seats extended again by a nice chart. But what if I tell you that our website is even totally responsive? That means on any device we will get useful information and a good design. In the user's view, we will get all the users that rated or commented a movie in our database.
In the details, we get an enumeration of all his activities. In this case, a rating for the fifth element as well as comments onto other movies. I hope you enjoyed the presentation of our web application, and now I will finish the whole presentation with some great famous last words from one movie. It is "Pull my finger." If you can shout the title in less than 10 seconds, you get 2 imaginary points from me. Thank you for listening.